All right. If we are going to write something in exponential form, I need to identify the base. I need to identify the exponent and the argument, because this is the order that it will go in for exponential form. So on number 1, what is my base? 10. What is my exponent? 3. And what is my argument? 1,000. So what will this look like when written in exponential form? 10 to the third power equals 1,000. Absolutely correct. So what about number 2? What'd you say? Yeah, 10 to the third power equals 1,000. That's exactly what it should look like. Number 2, what will this one look like when rewritten into exponential form? 10 to the 0 power equals 1. Is that true? Yes, anything to the 0 power is equal to 1. Is 10 to the third actually equal to 1,000?
Yeah.
Yes, and you can check it how? Put it in your calculator. 10 to the third power in your calculator should give you 1,000. For numbers 3 and 4, we're going to rewrite these in logarithmic form. So when we write it in log form, it starts with log. And then what comes after that?
10.
The base, which in this case is 10 for both of them. And then what would come after that? Yep. My argument is equal to, when I'm just talking about writing in log form, it's log base argument equals exponent. So I have to start my answer with log. And then what is the base on this? 10. So log base 10. 100 is my argument. Equals 2. Remember, the whole point of logarithmic form is to get the exponent on a side by itself. If the exponent is not on a side by itself, you have not written it in logarithmic form. What about number 4, the last one? What will this look like in logarithmic form?
Log 10
Yep, log base 10 of 10,000 equals 4. Wonderful. So far, so good on the bell work? Please pull out your 8-2 notes. Those are the ones that we started on yesterday. We were working on how to expand when we got to the end of class yesterday. We got through numbers 1 and 2. We did not have numbers 3 and 4 done. Did you have a question, Kaylin? What did you say, dear? You need 8-2? There you are. You're welcome. All right. When we're putting things into expanded form, which property of exponents do we do first? When we're putting logs into their expanded form, which property do we use first? Quotient. When I'm using the quotient property, what am I looking for?
If it's any division?
Yes. We look for division. Is there any division in the argument of my log?
Yeah.
Yes. So how many logs am I going to have? 2. This one is ln, and I mentioned briefly at the end of class yesterday, this is a log. This is a special log. This is a log that has a base of e. Do you guys remember learning about the number e in Module 7? You guys remember learning about e and we learned where it was on the calculator?
Oh yeah, the second and then in.
It's actually ln, but yes. It's ln, and that's what you see right here. It's called the natural log. So ln is a log, even though you don't see log. So I'm going to have natural log, ln. The numerator of this fraction is my first argument. So it's ln of 3w x squared. And before I get to the next log, the next ln, what am I going to see? Minus ln of whatever's on the bottom down here. This is my second argument. Y to the fourth. Remember, this is based in my properties of exponents. When I have a fraction, something to a power on top, something to a power on bottom, I subtract those exponents. That's why these are being subtracted here. So there's my quotient property. Which one do we go looking for next? Product. What should I be looking for if I'm going to use the product property? Multiplication, yes. So look for multiplication in my arguments. Here's my first argument. Is there any multiplication happening there? Yes. How many things are being multiplied? 3. 3 is being multiplied to the w, and w is being multiplied to the x squared. There are 3 things here that are being multiplied together. So how many logs am I going to need? If there's 3 things being multiplied, I need how many logs? 3. We need 3 logs. So it's going to be natural log, so ln of, what's the first argument here? The first thing being multiplied. 3 is the first thing.
3 and 2?
Nope, just ln of 3. My argument is just ln of 3. And then plus, because multiplication turns into addition, ln of w, the middle part, plus ln of x squared. Well, let's look at this guy. Are there any things being multiplied here? What? Is being multiplied to what? Nope. That would be 4y. It's being multiplied by itself 4 times, but they wrote that as an exponent. So I'm going to treat that differently. I'm going to do that in my powers step. Yep. So this right here is just going to come down. So minus ln y to the 4th. All right, we did quotient. We did product. What's the one that I do last? Powers. What do I look for when I want to do the powers step? Look for exponents, yes. Do any of the arguments have exponents in them?
Yeah.
Yes, which ones?
ln x squared.
ln x squared, so this right here is an exponent. It's going to come right in front of that ln. Anywhere else? Y to the 4th. So this 4 is going to come right in front of this ln. So I have natural log of 3 plus natural log of W plus, what comes after this one? Nope. Remember, we're doing our powers property. Where does that 2 go? So it's 2 ln of x. And then I bring down the subtraction. What do I see right after the subtraction sign? 4 ln of y. How many ln's do we have? How many logs? 4. That means we've got 4 arguments. This is an argument. This is an argument. This is an argument, and this is an argument. The way I know I'm done expanding is when I get to this step and I look at those arguments, I'm going to check to see, are there any fractions? Is there any division in any of those arguments? No. Nope. Is there any multiplication in any of those arguments? Any of the things that I have circled, is there any multiplication there? Are there any exponents there? No. Then I'm done expanding. This is my fully expanded expression. All right. Let's do that now with number 4. Which property do I do first when I'm expanding? Quotient. How do I know when I need to use the quotient property? Because I see division. Is there division? Yes. So the numerator will be my first argument. The denominator will be my second argument. I need how many logs? 4. When I do my quotient property, I'm going to have how many logs? 2. Log of the numerator minus log of the denominator. At the end, we're going to have more logs than that, but just at the end of this step, I have log base 5 of what's on top, 9v to the 5th, minus log base 5 of what's on bottom, y squared, w to the 4th. So far, so good? Yep. After quotient property, what do we do? Product. Looking at this argument right here, is there any multiplication happening in that first argument?
Yes.
Between what? 9. Between 9 and v. Does my second argument have any multiplication happening? Yes. In between y and w.
Aren't they added then once you do v?
Yep. So I'm going to have log base 5 of 9 plus log base 5 of v to the 5th minus, and now here's where you got to be careful. There are 2 logs here, but they both come after this minus sign. So I have to put this inside parentheses because I have to show that both of these came from the bottom. So they both have to be after the minus sign.
Why did you put that in the other one?
There weren't 2 things in the denominator on any of the others. There wasn't anything being multiplied. Whenever you have things being multiplied in the denominator, you're going to need parentheses there. Log base 5 of y squared plus what? Log base 5 of w to the 4th. Why do I have the parentheses again? If there's 2 things being multiplied in the denominator, we're going to need parentheses. All right, we did quotient, we did product. What next? Powers. I'm going to abbreviate that POW. So I'm running out of room here. What do I look for to know whether or not I need to do the powers step? Exponents. Do we have any exponents anywhere? How many spots? 3 spots. Where are they? Log base 5 v to the 5th. So this 5 is going to come in front of this log right here. Where else? Y to the power of 2. So that 2 stays inside the parentheses but comes in front of this log here. W to the 4th power. So that 4 is going to be after the plus sign but in front of that log. So log base 5 of 9 just comes straight down. Plus what? Not 2 log. What's that exponent? 5. 5. Log base 5 of v. What do I see after that? What comes right after the v? Minus. What comes right after the minus? Parentheses. All right, so I have a minus, then I have parentheses, and then I see what? 2 log base 5 of y plus 4 log base 5 of w, yes. Close your parentheses. How many logs are there total? 4. I'm going to go through and look at all of their arguments. So here's an argument, here's an argument, here's an argument, and over here's an argument. This is how I know when I'm done. Do any of those arguments have division in them? Nope. You may go. Do any of those arguments have multiplication in them? Nope. Do any of those arguments have exponents on them? Nope. Then I am fully expanded. No more division, no more multiplication, no more exponents in my arguments. So far, so good? All right. Let's learn how to condense. Condensed logs look like what we were starting from. This is expanded, all of this. This is condensed. If I did quotient, product, powers to get down here, what order do you think I need to do it in to get back up there? Powers, product, quotient. I'm going to go backwards here. All right, flip the page for me. Yes. I don't have any, I'm sorry. All right, so powers first. Please silence the phone. In my powers step, what I'm looking for, anything in front of a log and by anything I mean a number, becomes an exponent on the argument behind it. So I'm looking for any numbers that are in front of the LOG. If I see a number in front of LOG, it's going to become an exponent on that log's argument. So we said powers, and then moving backwards, what would come next? Product. For my product property, logs being added will become 1 log with their arguments multiplied. So first I look to see if there's any numbers in front of log. If there are, they become exponents. Then I look for any plus signs. Anything and everything that's being added between those logs, I take all the logs that are being added together, it turns into 1 log with their arguments being multiplied together. Last thing I look for is what? Quotient. If you've done the top 2 steps correctly, there should only be, at most, 2 logs left. So any logs being subtracted thank you. Any logs that are being subtracted will become one log with their arguments being divided. You're going to need a spare sheet of paper to do your corrections on. Do you need paper or do you have paper? I have paper. Okay, wonderful. You're welcome. All right, now it's really important to get the order of this one right. The first argument will be the numerator. Or the top of the fraction. The second argument will be the denominator. Or the bottom of the fraction. All right, I know I got a lot of words up there, but I want to make sure that you guys have something to look back at as we practice this, to know what we're looking for, and once we found it, what do we do with it? So looking at the first example, it's way down at the bottom of my screen, hopefully you can see it. Since I'm going backwards, I want to condense this down. We start with powers. Any number in front of a log becomes an exponent on the argument behind it. Are there any numbers in front of logs? Yes. What are the numbers in front of the logs? 2 and 7. So 2 becomes an exponent on the x right here. And 7 becomes an exponent on the y. So I'm going to have log of x squared plus log of y to the 7th power. So far, so good?
Yep.
All right. What's my next step? I did powers, product. That's exactly right. Yep. I have 2 logs that are being added together, right?
Yeah.
Here's the argument of the first log. Here's the argument of the second log. Because there's a plus in between, we will multiply these 2. We get just 1 log, log of x squared y to the 7th. What am I supposed to do after the product step? After the product step. Powers, product, then quotient. How do I know if I need to use the quotient property?
If there's a subtraction.
If there's a subtraction symbol.
Yeah.
Is there any subtraction between logs here? No. We're done with that one. One of the ways you know you are done is you should have only 1 log left. 1 LOG and everything else is in the argument.
So even if you don't make it to having to do a quotient step, as long as there's 1 log, then
Yes, only 1 log left, then we're done. I'm going to pop this up a little bit higher on my screen for us to do that next one. Let me copy my work on here. All right. And I'm going to make a quick little note. Quotient. There was no subtraction. So we skip this. If you see subtraction, we can't skip it. But if there's no subtraction, we get to skip that step. I want you guys to take just about a minute. See if you can do number 2 on your own. It's very, very similar to what we just did, except it has 3 logs. See if you can follow the process to condense this. Coming. That looks fantastic.
I got it right.
You got it right.
Oh my god, I'm so sorry.
Yes, sir. Yep,
Oh my god.
that's exactly right. So you would circle
This is why I
that
need
as
to
your final
invest in a
answer.
highlighter. I definitely do not have it.
Do I need to do the powers step? Yes. How do you know?
because you have the numbers in front of the log,
We have numbers in front of log. What is the log that I have this time?
natural log.
Natural log. We'll learn more about natural log next week, but we're using the notation now. So these are going to become exponents on the arguments behind them. So I'm going to have natural log of z to the 6th plus natural log of x to the 4th plus natural log of w to the 5th. What do I look for to see if I need to use the product step? Addition. Is there any addition? How many logs are being added together? 3 logs are being added together. Here's their arguments. This guy here, this guy here, And this guy here. What will I do with these three arguments? Multiply them together. Since I have 3 logs that are being multiplied, this is going to collapse, condense into how many logs? Just 1. So I'm going to have natural log of z to the 6th times x to the 4th times w to the 5th. Do I need the quotient property? Nope. Why not? There's no subtraction, so I'm done right here. No subtraction. So we skip this. I like it when we get to skip a step. Number 3, are we going to have to use the quotient property on number 3? Why? We have subtraction. Now, there's something I don't like about the way this one is written. It's in the middle, right? There's no parentheses. The minus is in the middle. When we were doing our expanding, when we had a minus, it was always showing up at the end, right? I really want that minus to be at the end. So I have to grab the minus sign and the log behind it, and I'm going to move it to the end. If I don't take the time to move it to the back, there's a good chance I'm going to mess this up. So let's write down what I would have then. I know it's going to start with log base 7 of 3. If I move all of this to the back, what would come next? Yep. Plus log base 7 of 5. And then at the back, I would have minus 2 log base 7 of 4. So far, so good? All right. So now that I've got it in the right order, I have all the minus at the end, I'm going to start condensing. What step do I start with when I'm condensing? Product? Powers. There we go. Starts with a P. Powers. Do I need to use the powers property here?
Yes.
How many times? Once. Where?
The 2 logs and 4.
Yep, this guy right here. This 2 becomes an exponent on the 4. It doesn't touch the minus sign. It just touches the 2. So I would have log base 7 of 3 plus log base 7 of 5 minus log base 7 of 4 squared. So far, so good? All right. What property do we do after powers when I want to condense? Product. Do I need to use the product property? Yes. How many logs are being added together? 2 logs are being added. What are their arguments? 3 and 5. What do I do with these? Multiply them. So I would have log base 7 of 3 times 5. We are multiplying them. What do I get when I do 3 times 5? 15. All right, so I'm going to write that down. Log base 7 of 15 minus log base 7 of 4 squared. Is there any more addition between logs? No. So then I go on to what step? Quotient. We know we have to use the quotient step because why? Because there's subtraction. So I've got subtraction in between. What do I do with this log?
Numerator.
Numerator. So this one goes on top. What do I do with this log? Denominator. So it goes on the bottom. How many logs will I write down? Just one. Log base 7. This turns into a fraction. I have 15 on the top. And I have 4 squared on the bottom. That's our answer. Could I write that another way? Like, do we know what 4 squared is? What is 4 squared? 16. So I could write this as log base 7 of 15 over 16. It does not matter which way you write that. You do have to multiply the 3 and the 5 together. But I am fine with you writing that denominator either way, either as 4 squared or as 16. Has the same meaning, just looks different. All right. Let's do number 4, and then I think we'll call it a week. What do you guys think?
Yes, it's too much.
Do you see why I said we're going to keep practicing this on Monday, though? We didn't get through everything, but I think we're all kind of done.
It's like the first thing I've ever understood in your class.
Yes, I'll take it. I will take it. What step do I start with when I want to condense? Powers. Do I need to use the power step on number 4? Yes. How many places? 2. What am I looking for? Yep, I'm looking for numbers in front of log. This one has no number. This one does have a number. And so that becomes an exponent. There's a number right here. So that becomes an exponent. There's no number right here, so I don't do an exponent. All right, so I have
Log base 5 of x, y squared.
Yep. When I get to that step, yes. And you're welcome to combine those steps together, yes. Log base 5 of y squared minus, and then we have parentheses, log base 5 of x squared plus log base 5 of y. As you guys become more comfortable with this process, if you want to combine steps together when you're doing your work, you can. I don't have to see all 3 steps written out. I'm writing it out as 3 steps so that we understand what we have to do and everything that we have to look for each time. But if you look at a problem like number 2 and you're like, I already know what the answer is, you're welcome to just write it down. All right, after powers, we look for what? Product. Do I need to use the product property? Where do you see plus signs? 1 plus sign right here. So these 2 things are going to get multiplied together. Anywhere else? Inside the parentheses. So these 2 things are going to get multiplied together. So log base 5 of x y squared minus, do I still need the parentheses if I condense it down into just 1? Nope. If I have it as just 1 log, I don't need those parentheses anymore. Log base 5 of x squared y. We did powers, we did product, now we do quotient. Do I need to do quotient? Yes. How many logs are being subtracted? 2. If you've done the other steps right, there should only be 2 logs left at this point. Here's my subtraction. What do I do with the first one? Numerator, this one goes up on top. What do I do with the second one? Denominator, this one goes on the bottom. How many logs will I have? Just 1. So I have log base 5, and then I have my fraction as the argument. What goes up on top? xy squared. What goes on the bottom? X squared y. Can I simplify that at all? Can I use my properties of exponents? I can. Some of them are going to cancel, yes. So look at the x's. Are there more x's on top or bottom? Bottom. Will the one on top cancel with one of the ones on the bottom?
Yes.
Yes. Here, let me write this out a slightly different way. Do you have to simplify? You should simplify. This is x times y times y. On the bottom, I have x times y. That's what x squared and y squared mean, right?
Yeah.
One of my x's will cancel. One of my y's will cancel. So what would I have left? X over y? Y over x. I have one y left on top, and I have one x left on top, or on bottom. You should. When we get to the test, if you leave it as xy squared over x squared y, I'm not going to take off points, because what I'm looking for on a question like this is, can you take it from its expanded form down into its condensed form? How do I know when it's fully condensed? There's only one log.
Please tell me we're done.
We are done for today.
Thank you, Jesus.
All right. On Monday, we're going to keep practicing this idea right here. The homework that I passed out yesterday, that I told you yesterday was due on Monday, I pushed that to Tuesday so that we have another day of practice with it before you have to turn that in to me. All right? Yes. Yes, you may. Don't forget your graphing homework is due today, like right now. 8-1 homework, I just changed that due date. This is going to be due on Tuesday. What else is due today? Bell work. Homework in one basket, bell work in the other basket. Other than that, have a fantastic weekend.